Hi guys, my name is Adil and I wanted to make this video on explaining the states of matter, that is solids, liquid and gases, basically the chapter 7. So I just wanted to highlight some basic concepts. Firstly, I'm gonna go ahead and make I'm gonna go ahead and make three different structures. So suppose this is box A, this is box B, and this is box C. So in box A, we have particles that are like extremely close. Or actually, box A is made up of particles that are extremely close and packed together like this, right? And in box B, we have particles that are close, but not as close as they are in A. They're just like we could say relatively closer. They are closer, but relatively they're like far apart from each other as compared to A. And for C, we have particles that are very far apart. So these are basically the three states of the matter. So this is A is solid, B is liquid, and C is a gas. Right. So the first thing that I want you guys to see is in solid, the particles are like really close to each other and are like really packed together. So they don't have a room for movement and changing the shape. So that's the reason why like whenever we see some solid like suppose a pencil or a solid cube or whatever, it never changes the shape. It stays the same because particles are like so close to each other that they never get a room to change the shape. In liquid, particles do have some space here. See, particles do have some space in between them, so they can relatively move around. And as so, the liquid changes the shape. That's the reason why if you put water from a bottle to the glass, in the bottle the water took the shape of the bottle, but in the glass it took the shape of the glass, right? And in gas we don't have a fixed shape, we have no fixed shape, right? So in solids and liquids, so fixed shape, fixed shape, uh not fixed shape, right? Shape not fixed. And then um yeah, shape not fixed. Fixed. Okay, what about the volume? So what if so we know that solid doesn't change anything, like it stays the same wherever you're gonna put it, the solid's gonna stay the same. So fixed volume. What about the liquid? Okay, what if you have some liquid in one glass and then you put the same liquid in another glass without losing a single drop? Do we change the volume? Actually not, right? Although we change the source, like for first it was in one glass and now it's another glass, but still like even if we change the shapes of the glass are different, glasses are different, the volume is like the amount of water is still the same, right? So fixed volume. And for gases, there's no fixed volume. Okay, these are some extremely basic high school properties of for the solid, liquids, and gases. Just wanted to remind you of the distinguisher feature between both of them. Now, for this class, what is most crucial for these is I want you to learn this table, right? Okay, this is called a heating curve. I'm not going to go into deep um, complications of this, but what I'm going to tell you is, suppose we have water. We're talking about water here. So we're gonna have two types of lines. One is slant line and one is horizontal line. So in the slant lines, the temperature will change, and in the horizontal lines, the temperature is going to be constant. Okay, so if you look at this, and also, so we see two horizontal lines, right? This is the first one, and this is the second one. So the first one is going to be the melting point, and the second one is going to be the boiling point. Okay, and this is on y-axis we have temperature, and on x-axis we have energy. Okay, now suppose we're here. We have ice. Right now we have ice. Also, like I forgot one thing. So when we are at the slant, right, we have only one state, only one state. Like it's either going to be a solid, a liquid, or a gas. Not like we have both solids and a liquid, solid and liquid and a gas. Only one state. And here the horizontal thing, we're gonna have um we can have two states. So here, suppose we have some ice here, right? This is 0 degrees and this is 100, right? And let's say it's degrees. Okay. Now we have ice here at this temperature. We start from this temperature, right? And then we start adding some heat to that ice cube. Okay, what happens? First, the ice is gonna melt, right? And then let's suppose let's suppose we put the ice cube inside a heating pan. So first the ice is gonna melt, right? And then the water is gonna evaporate at certain temperature, right? So the process for the ice to melt is actually this process. At 0 degrees Celsius, the water is gonna melt. You don't have to remember the melting point for water, but it just for the sake of this video, um, at 0 degrees Celsius, the water is the ice cube is gonna be converted to water here. So at this state, we only have ice. As soon as we reach at this point, we're gonna convert the ice to liquid. So at this stage, as I said here, right? It's I mean, when we have a horizontal line, we're gonna have two states. So at this, we have a solid, we have solid and liquid, solid ice cube and liquid. At this point, we're actually like the energy is being used to convert the solid to liquid, right? So we have a mixture of solids and liquid here, and now as we go up from 0 to 100, the temperature increases and there's only one state. Here the state is going to be the liquid only. So at this point, all the liquid at this point, it's all liquid. It's all liquid. At this point, we're about to start liquefying. Okay, and here we have liquid and solid. Okay, now as soon as we go up, we have we have liquid here. Remember, go back. I said the slant has only one state, so we only have solid here. Okay, now here as soon as we reach 100 degrees Celsius, which is the boiling point, we're gonna convert the liquid to the gas. So at this stage, we have both the liquid and the gas, right? And at this point, all the liquid is converted to gas. Now here we only have gas. So if you could follow along with this video, like, and understand, even if you're given different liquids and you know the melting point and the boiling point, uh it's going to be easy for you. But I just wanted to explain this heating curve, and hopefully it hopefully it makes sense to you. Thank you for listening and take care. Bye.